Good evening, everybody. Welcome to night, what night are we on? 6? Wow. Welcome to night 6 of Lambda School's mini boot camp. We're covering more JavaScript this week, so I'm glad to have you guys with me. My name is Deandra Ryan Moss. I'm an instructor here at Lambda School, and I will be teaching you live tonight, as usual, from Bisbee, Arizona. So thanks, everyone, for coming tonight. I hope you guys have gotten some time to catch up on last night's episode. I know it was a holiday. If you haven't, that's fine, stick around. We're not really building off of anything we saw last night tonight, but you will need to know what we learned last night for tonight's homework. So just in general, make sure you catch up on that if you haven't done so already. So let me talk a little bit about Lambda School, about this mini boot camp, and then we can get started with coding. Tonight we're going to be looking at two very important data types in JavaScript called arrays and objects. So, all right, let's talk about Lambda School. Lambda School is a 6-month computer science and web development bootcamp. So we are an immersive school that teaches you how to become a programmer in 6 months entirely online. So we take you from basically 0 to the point where you are able to be hired. It's a great option for anyone looking to get a job as a computer programmer or web developer without going through an entire 4-year program, which honestly, 4-year CS programs don't even teach you a lot of the practical skills anyways. So it's just a good way to go all around. We do focus on web development in Lambda School. So that means front-end web development, that means back-end, that means frameworks. That means that you'll be working on your own projects and apps. But we also cover some more computer science-y aspects of programming. So while we focus on web development, we want to round you out. We'll also cover a little object-oriented programming, Python, and algorithms as well. So after the 6 months, you're going to come out on the other side ready to hop into that job on the field and as a really well-developed, well-rounded programmer. As for the hiring process afterwards, hiring is really important. We know that as much as we all love learning, we know that we're in Lambda School pretty much to get that job at the end. So we do offer a lot of hiring resources. So as far as what happens after you're finished with the curriculum, we don't just drop you off and say, go out there in the world and find the job. We want to help you from start to finish, and that includes the hiring process. So we have a hiring team. We help you with things like interviews, resume building, as well as getting you connected with companies that you're interested in. So that is a really important part to us. One, because we want you to get that job. We want you to go out there and show everyone how much you learned at Lambda School. Also, because of our income share agreement. So you do not have to pay anything to attend Lambda School. It can be totally free until you get the job. So we don't get paid until you get hired. So everyone is like, yeah, we want you to get hired. So that's Lambda School for you, a great place to learn. We also provide hiring resources, and we also have an option so that people who aren't able to pay the full tuition up front can still attend. So if you're interested in applying, feeling like you're ready to apply and take our application challenge, then reach out to Karen Zachary in Slack. She's also just a great person to answer any questions you have about the admissions process or the program. So, and speaking of Slack, I hope you guys are all in Slack tonight so that you can interact with me during the lesson. So on to the lesson. This is the mini boot camp. It is a little mini free course that we do to ramp you up to the point where you are ready to actually start Lambda School. So we cover some front-end topics. Last week was HTML, CSS, JavaScript. This week is all JavaScript. And JavaScript is building. So as I said, if you haven't seen last night's episode, that's okay. But if you're hopping in for the first time and you don't have any JavaScript experience, this might be not the ideal place to start. But all those videos are on YouTube, so you're welcome to go check out what we've learned so far. But let's go ahead and actually get to the JavaScripting now. So tonight we are going to, as I mentioned, talk about arrays and objects, both very critical. I mentioned last night, and I think last week as well, this idea of dry programming in a way so that you don't have to repeat yourself, so that when you're doing lots of similar things, you can abstract it in the code in a way that makes your code really elegant and easy to use. And that is tonight is going to be another example of where we learn some skills that will help us be really refined, dry programmers. So arrays and objects are kind of different from some of the data types you've seen so far in that they're ways that we can group like data together. So when we have multiple pieces of data that have some common thread, we can actually put them together in one variable. So that's what we're about to see tonight. Let me go ahead and share my screen so that we can actually learn how to create them. All right, here we go. Okay, so let's start off with an example of a situation where we might want to use an array. So let's say that we had a list of, I was trying to create a list of all the cars I've ever owned. So maybe I start with car 1, car 2, I can spell, always a challenge. There we go. As you might have noticed already, because I'm just typing in silence over here, I am not following my #1 rule of don't repeat yourself. I'm in fact writing something that is very repetitive here. So I kind of already gave away that this is a bit of a what not to do example, but hopefully even without me saying that, you can see why that is. So let's break down why these lines of code that I just wrote are not good practice. I am, of course, using totally correct syntax in terms of creating variables, declaring them, but it's still not a good way to go. So for starters, we can see that I'm doing something very repetitive. I've declared these 5 different variables. Each variable name there's kind of a pattern to it, right? Clearly, they're all related, and so I was just declaring out these variables that all are related. They have similar variable names, and content-wise, they're connected to each other. So already it was kind of repetitive how I was even typing it out, which is kind of your first clue that this might be a situation where there's a better way to go about it. The next clue, and maybe the more important thing that makes this bad code, so this is what not to do, is the fact that so these all 5 of these are related pieces of data. They're all this list of these cars that I've owned. And as a user, as a human being, it's clear that they're related because of the variable names, right? They're all named almost the same thing, but with incrementing numbers. So any human reading this code is going to be pretty clear to them, like, okay, these are all connected. But we can't think about things just from a human's perspective because we're writing code. So let's think about this from the computer's perspective. So the computer has no way of interpreting what the meaning is behind these variable names. So even though these are connected, there's really nothing in the actual structure of the code that says, hey, these things are connected together. As far as the computer is concerned, these variable names could be really anything. So these are all floating in memory in totally disconnected ways, which means that if we're trying to access this list as a whole, we have no way of getting to it. We can look up each individual point using the variable name, but there's no way within the structure of this variable to say, one, that these are connected, or to denote the order of them. And that's not good. So that is exactly where arrays come into play. So arrays are a data structure, which means that they're a way of grouping like data points. This would be a great example of a collection of like data points or like variables. And what's really cool about arrays is that they're ordered. So while arrays don't have to be ordered, or the content in them doesn't have to be ordered, which I'll get into in just a second, they do work really well for ordered data like this. So let me go ahead and type this out in a way that works. So instead of creating a separate variable for each car, I can create one variable for the collection. And I'm going to name it cars. By convention, we usually, when we're creating arrays, we want to name them with plural variable names. So that will help, one, tell our fellow programmers we're dealing with an array, but it also makes sense because arrays are always collections. So I'm going to create an array to contain all of these cars. So this is how you would start declaring an array. Right now, this is just an empty array. As you can see, it's pretty similar to declaring any other variable type. The difference is that we use these brackets. So as you've seen, we have different ways of indicating what type of variable we're creating. For example, we use quotes with strings. For arrays, we use these brackets to say, hey, we want to create a collection of items. So it's perfectly fine to create an empty array and then start to fill it up later, but I'm going to actually fill it up from the get-go. So I'll go ahead and actually put all these cars inside of here. All right, so there we have it. Here's what not to do. Here is good programming. Yay. Okay, so let's actually just comment out this nonsense here because we do not like it. So let's talk about what happened here syntax-wise. As I mentioned before, we always want to make sure we have our hard brackets when we're creating arrays, and then inside of the array, we put our data points separated by commas. So I've typed out each of the cars, just typed out a string. If we want to put strings in an array, make sure, you know, they're actual strings instead of just floating words. And we separate each of them by commas. As a note, an array does not have to contain strings. We could not have an array of numbers. As a note here, we don't have to type out the different items on separate lines. I just did that in this case because it wouldn't have all fit on one line, so I think it's more readable this way, whereas with the numbers, they all fit. So that's going to be either your own personal choice, or if you're working on a code base, there might be a style guide to how to type them up. The important thing is that you have everything separated by a comma. That's going to be really key syntax. So everything in an array, you can have arrays full of strings, you can have arrays full of numbers, you can have arrays full of arrays, you can have arrays full of functions. You can have mixed types in arrays. That's sometimes not a good move. I'll talk more about that later. But here you go, a couple examples of arrays. So let's talk a little bit more about why this is a better way to put this collection together than this what not to do example down here. So it just solves all the problems that I listed before. For one, all this data is clumped together. There's a way to access this list. So cars is a variable name that I can now call on to actually see the entire list. So if I want to see all the cars, I don't have to know what their variable names are, how many there are. I can just look in one place to see the entire collection. Really useful. Another thing that's nice is that the order is preserved. So the order here was based on the order they were declared in, but also by the variable name, but that's not very clear to us. Whereas the order here is actually built into the structure of the array, which we'll see in just a second with indexing. So this is really a much better way to do it. Everything is stored in one place, and we're able to access the order in a really built-in, intuitive way. So on that note, let me go ahead and actually start to look things up on here. So if I want to look at, well, let me talk about the indexing. So remember how with for loops, by convention, we would start counting at 0? It turns out we're about to see more examples of that 0 indexing. So the same thing applies with arrays. When we're thinking about sort of the slots in the array, we always start at 0. So we would think of this, the Privia as being in slot number 0, the Econoline as being in slot number 1, Jetta in 2, the Echo in 3, and the Frontier in 4. So don't worry, you will, not to be negative, but you will mix this up. Every single new programmer has to get this confused about 80 times, and then it's stuck in their minds forever permanently. So yes, the first item is in spot 0. The second item is in spot 1. The third item is in spot 2, etc. So for as far as index goes, for something with 5 items in it, there's spot 0 up through 4. And we use those spots to look up items in our array. So If I want to look at the entire list, I would call my variable name. But maybe I just want to look at the first car I ever owned. So remember, for the first car, we use index 0. So to look up a specific item in an array, we use those hard brackets again, the same ones we used to declare, and now we just put in the index, and that will give us the first item in the array. If we wanted the third item, we could look up it too. So there you go. If we tried to put in something like 5, even though there are 5 items, remember there's nothing at index 5, we get undefined. And if we put in some big number that we definitely don't have the item, we just get undefined as well. So that's how indices work with arrays. We can look up individual items in our array using the index. So it's really nice because if we know specifically where something is, like, we know econolines in slot 1, we can look it up. But even if we don't really know what's in the array and we're just curious, oh, what's the second car, we know where to find that at index 1. So this bracket notation isn't just used for lookup. It's also used for adding items to our array or redefining things. So let's say that we wanted to add a 5th item, maybe, or not a 5th, a 6th item at slot 5. See, even I mix it up sometimes. So let's say tomorrow I go out and I want to buy, what car should I buy tomorrow in this weird universe? Let's say that I want to buy a Mustang. I go out tomorrow and I buy a Mustang, so I have to update my cars array, of course, and I know that I have 5 items in here, which means that the next item, the 6th item, goes at index 5. So I can actually use bracket notation and then assign a value in. And notice the syntax is really similar to declaring a variable, but instead of actually declaring any variable name, we just grab the index of our array, use the single equal sign, always used for assignment, and then put in our value. So if I go ahead and do that and then look at the whole list, I can see that the Mustang has been put at the end. So there you have it. That's how you can use indexing to look it up. You can also use indexing to overwrite things. So as it were, the Jetta I owned was a total lemon. Really traumatic year of my life, saving up money to constantly fix it while I was in college. So let's say that I want to try to rewrite history. So I'm going to overwrite that to pretend that I actually had a Mustang then. So now I'm doing the index of something that already exists, but I'm storing something on top of it. This works too. This will just overwrite whatever was at index 2 before. So now when we look at the list, we see that where the Jetta once was, there is now a Mustang, which would be a much better college memory. So there you go. That's another way that you can use the indices to look things up. The final thing you can do is you can actually delete items. So maybe instead of rewriting, history with a Mustang, I just want to get rid of it. So in that case, to actually take it out of the array altogether is a little trickier, and I'm not going to show that to you. But you can always overwrite it with null. So we've seen null and undefined as kind of our slightly mysterious variables that we use to denote missing data. So if we even just didn't know what this car was, we can put in a null value. And that indicates to another programmer or user that this bit of data is missing. So subtly, the difference between putting in a null versus just getting rid of it is that instead of saying that I went straight from the econoline to the echo, we're kind of saying, okay, we know there was a value here, we just don't know what it was. So there's a little example of where you might see a null value. So the next thing something I want to briefly talk about before we move on, which is a common question that comes up with arrays, has to do with const. So maybe some of you guys are even asking yourself this already, which is that, wait a minute, constant is supposed to be for constant variables. So how come I'm allowed to add things or overwrite things in this array when I use const? Shouldn't that throw an error? So this is another one of those subtle things to conceptualize. So it's true that cars is constant. So let's say that instead of just changing individual values, we tried to put a whole new array in cars. So I know these aren't cars, they're just numbers, but if I tried to overwrite cars with a totally new array, or maybe even something totally different, like a string, I would get a syntax error. So it still is a constant variable. We're still not allowed to totally change what it's equal to. But arrays are designed so that we can manipulate what's inside of them. So while we're allowed to change what's the content of it with const, we're not allowed to change the whole thing. A little metaphor I like to use is think about it like a house. So when we declared cars, we built this house meant to store a bunch of different data. So we can do a lot of things inside of the house. We can move in furniture, move it out, rearrange the rooms, even knock down walls, and the house is still the same house. But if we tried to demolish it and put a whole new house in place, then we're violating our const and we'll get an error. So hopefully that addressed a common concern that some people might have just from the get-go. So there you go. That's the basics of arrays. And hopefully just from seeing how indexing works, you're already seeing why this type of code is way less useful than putting everything in an array like this. Let's talk about some other cool things we can do with arrays. So arrays, just like strings and other data types in JavaScript, have some properties and methods that also make them useful. So just like strings, they have a length method. Length being 5 on this one. So another little reminder with zero indexing. Even though we only go up to index 4, we still have a length of 5. So length is really intuitive. If we have 5 items in the array, our length is 5. Even if one of those items were null, it would still be considered to have a length of 5. So the length property is super useful. I'll show you in a minute one of the most common uses of the length property. But first, I want to show you a couple methods. We learned a lot about functions last night, so we have a few more kind of tools and vocab words in our tool belt to talk about these methods. But as a reminder, methods are functions, but they're specifically built-in functions that are built in on different data types or objects in JavaScript to make them more useful. So we've kind of seen a couple. We've seen some functions built into global objects like our math functions, or console log is another method that's built in. We've also seen a couple of string methods kind of in passing. Let me show you a couple array methods. So you might have noticed that when I added that next element, so if I decided to add a new car on the list, I had to put it in at index 5, right? Because we're up to 4, so if I want the next one, it's 5. And that's really easy when the code is in front of me because I can just count these up. But sometimes we might not know exactly how many cars are in here. So there are a couple ways that we could figure out what to do. For example, we know that the length is always going to be the next empty spot. So we could actually get our length and then change this 5 from cars.length. So notice that now, no matter how many items are in here, even if I went ahead and actually added something else in manually, and let's see what's in cars. So notice that this code is dynamic now. So if I had hard coded in 5, it would have replaced the Mini Cooper instead of actually putting in the next one. So we can use our length to actually figure out how many things are in here, but there's an even better way to do this, and this is a method called pop. So, or sorry, push, not pop. We'll talk about pop in a second. So pushes an item onto the end of the array. So we don't even have to worry about what index this is going on. This will just push it on the end no matter how long it is. So if I look in here, this is on the end, and no matter how many things I add in here, it just keeps putting it on the end. It doesn't care how many items are in here. It just always always puts whatever you put in on the end. So let's use this as an opportunity to talk a little bit about some of our concepts from last night. So as a reminder, first of all, cars.push is a function. So this here is a function. And a function is just like unused potential. It's like a machine that hasn't been turned on. This bit of code is a function call. That means we've actually executed our function, and we can tell because there are the parentheses. We can think of parentheses as the button we press to execute the function. In this case, push takes in one parameter. That parameter is just some value that we're putting inside of our array. And in this specific case, the argument that we put in is the string Mustang. So we've called the function, and we can see when we look inside it that something has happened. Mustang's been added on the end. As far as a return value go, we can actually find out what the return value is by just executing it. And as it were, push's return value is the number 6, which happens to be the new length of the array. So before it was length 5, after we pushed, it's now length 6. So something kind of interesting about push is that we may not even use the return value. So we could want to use the return value. We could save it in a variable if we wanted, like this. Maybe that length could be useful for us. But oftentimes when we're using push, we don't even care about the return value. We're just using it to put a new item on the array. So that's kind of this cool thing about methods, is that sometimes they don't have return values, or we don't even care about the return values, since we're actually using it to alter the array itself. So that's push for you. The next method I want to show you is pop. So cars.pop is a function. Cars.pop with parentheses is a function call. So when I pop something, what it does is it removes an item and then returns it. So notice that when I just call it, my return value is frontier, the last item in the array. But as with push, something happened behind the scenes, which is that frontier was actually popped off. So if I called cars.pop several more times, notice that we've popped over half of the cars off with these 3 calls to pop. So pop is another really nice, useful way if we want to remove something from the end of an array. So there you go. Now let's talk about looping with arrays. Looping with arrays obviously is pretty similar to looping with anything else, but loops and arrays go together pretty well, so it's nice to just kind of go on there. All right, so let's go ahead and write this array. And I'm just going to console log all of the items in the array. Give me 1 second to write this out, and then I will break down everything this code is doing. So, okay, I've gone ahead and written out a loop that will loop through this whole array and log out everything. We can see the console logs over here in white. So let's start by looking at the conditions. Once you've done this a few times, you can write a loop for an array in your sleep because it's always the same. We always start our index at 0, of course, because we know that's where the indices start for arrays. And we always do less than cars.length because we know that the last item is going to be 1 less than the length. So we always do I less than, well, not always cars.length, but whatever the name of our array is, .length. So a really useful place to use that length property. And then we always do I++ because we just want to walk through. So I went ahead and at each point I used indexing, and notice that you don't have to put in, as we kind of saw, you don't have to put in an explicit number. You can always put in a variable that resolves to a number. So cars at I will change every time. So the first time we run through this, cars at I will be cars at 0. We'll grab an item, and then we log it. The next time, it will be cars at 1, etc. So we can even see that pretty clearly if we just log out I as well as item. can see that we loop through all the indices and we're able to look up each item there. So, and then I logged each item. Really, you could have done this on one line if you wanted. I just wanted to split it up so it was really clear what was going on. So there's the same thing just done on one line. I just went ahead and looked it up in here and threw that in the console log. And the reason I was able to write this line of code is because this resolves to a string. So this will be read first, it'll resolve to a string. And of course, we know we can pass strings into console log and then console log those strings. So there's just a little mention of looping with arrays. Honestly, there is a slightly better way to loop with arrays called the for each loop. It's a little more advanced. You will see it on Thursday, but for now, for loops are going to be the way you want to go with arrays. So there you have it. Those are arrays for you. Just as a little review before we move on to objects, arrays are really great for collections of data. They work super well for collections of ordered data, but not necessarily. So if, for example, I just wanted to create a roster of students, I could put, start to put some student names in here, etc. And I notice that there's no order to these students per se, but they are related. So things don't have to be ordered, to go in an array, but they end up having an index order regardless. So, so arrays work for related groups of data, ordered or not. They're really useful for storing them because we have a single variable where we can not only find everything in the list, but we can also easily look up things in the list with our bracket notation. We can add things to the list with a push. We can pop things off with pop. We can also check out the length and use a ton of other methods, honestly. So I just showed you two, but there are a ton of methods built into arrays. We will learn a couple more on Thursday night, but there are a bunch out here. As always, you won't need to know any of these for tonight's lesson, but you're welcome to look them up and play with them if you're a little curious. And I'm just on MDN. You can look up arrays on MDN or just Google array methods, and I'm sure a bunch of resources will pop up. And so whichever one you go to, so I'll go to pop, which we already know. MDN's really nice because it will up here give a description of what it does, what it returns, and then show some examples up here as well. So really nice, and then even a place to play with it. So really nice because all that information we need to know about how to use each of these methods is all online for you to view and play with and learn. So, yep. Arrays, we love arrays. Great way to store bits of data together. I do see a couple questions about arrays in Slack. I'm actually going to answer a couple right now, just because we're going to spend the rest of the lesson talking about objects. So I'm going to answer a couple of these questions about arrays right now, but then I will move on to objects and have an all-around Q&A at the very end. So yeah, let me answer a couple of these questions. So one is about, I see there's a little Slack discussion about this, but this question about what happens if we skip an item. So if I decided, you know what, I want to just project into the future that my 14th car will be what's a really lame car? How about a Corolla? Sorry if anyone owns a Corolla, not to talk smack on Corollas. So I'm like, yeah, car number 14 is going to be a Corolla. So notice that what will happen is that the array will actually fill everything up until that item with undefined. So I'll get rid of that for loop. So if I look at, it's kind of weird because if I look at cars, it'll do this kind of weird notation of 9 empty items, but essentially all 9 of those are undefined. And if I look at length, it will still say there are 15 items, even though about half of those are missing, actually over half. So that's kind of a weird thing. You don't see this very often. There might be some cases where it's useful, though, to put something in a later index and skip over spots. So we had a little question about the difference between a method call and a function call. So a method is just a type of function. So not every function is a method, but every method is a function. So For example, if I just wrote out a function and then called it, this is a function call. But it's not a method call because sample function isn't a built-in function on some object. But if I did cars.pop, it's still a function call because pop is a function, but you could also call it a method call because it's a specific type of function called a method. So if we're talking about methods, function call, method call is interchangeable. All right, we have a question about why it says prototype on MDN. We will talk about the prototype tomorrow. So that will make more sense, I think, after tomorrow's lesson. But just know that everything after prototype down here is just a method you can use on any array. So not a very satisfying answer, but we will learn that tomorrow. And then Teresa asked, with the students array, could you return them in alphabetical order? So yes, of course we could do that because we're computer wizards and we can do anything. But that's not a trivial, not necessarily a trivial project if we wanted to actually write out the logic. However, there's a little method called sort. So I'm too lazy to type out the student's name, but if we wanted to not have to write the behind the scenes logic, it turns out that there is a built-in method called sort. So you just learned a new method. And this will actually sort them in order. What's cool about sort is you could actually customize it too, which is fun, but way outside the scope of this lecture. But now you guys learned another fun little method you can use. Okay, so that's all the questions I'm going to answer about arrays for now. I want to move on to objects. But if you have any array questions that are lingering, you can still ask them at the Q&A at the end. So, okay, let's talk about objects now. Objects are another way of storing like data. So let me give you another little example of a collection. So let's say that I wanted to create a collection of data called my info. And I'm going to start by putting in my name. I'm going to put in my age. I'll put in my hometown, my social security number, just kidding. I'll put in the city I live in, and let's do whether or not I know JavaScript, which of course, even though sometimes it might not seem like it, I do know JavaScript. So true for knows JavaScript. Cool, so here is a little array full of some info about me. Now, this kind of works. As mentioned, we are allowed to put mixed data types in an array. So syntactically, there's nothing wrong with this. It's true that everything I put in there is related, but you might see why this isn't as good of as useful of an array as the last one. So just looking at this array by itself, it's kind of confusing about what this actually contains, right? So, so you know what it contains because I'm speaking out loud and I just explained what all of these is. You know, we pretty clearly, that's a name, 26. We could probably guess it's an age, but maybe it's how many cats I own. Don't actually own 26 cats. That would be pretty intense. But, you know, maybe, and then it's like, okay, well, Salt Lake City and Bisbee are both towns, but what's the difference? Why are there two? And then true, like who knows what that refers to? By itself, without me verbally explaining what it is, that's really confusing. So we don't like that. I mean, true, I could put a little comment up top explaining everything. But while comments are nice, if we can actually build the data into the code in a way that doesn't create confusion from the get-go, that's even better. So instead of trying to group these items in an array, I would actually use something called an object, which is similar but a little different. So once again, this is a what not to do example. I will comment it out and create a way better my info collection in object form. So syntactically, objects are really similar to arrays, whereas with arrays, we always started with our little hard brackets. Now we're going to use curly brackets. So So that's really the only reason that we use curly brackets versus hard brackets is we're telling the code, hey, what's coming up is now an object, not an array. So what's great about objects is that we can label the data. So now I could do the label of name, and then I could put my name in. I could do the label of age, the label of hometown, and now all of a sudden, all of those ambiguity problems we had up here are solved. Built into the data structure itself, we have these labels telling us what everything is. So let's break down the syntax here. As I mentioned, we use curly brackets instead of those hard brackets. And just like with arrays, all of these things can be on one line if we want, but I like to separate it out on separate lines. It's just way more readable that way. So we start with the label, the key. So you can put these in quotes if you want, but you don't have to, so I usually don't. So, and this is something we come up with. We get to name these labels. We can name them really whatever we want, as long as it's some sort of bit of text. We want to name them useful things. We can't have two things with the same name. That doesn't work. I couldn't have town and town. For one, it wouldn't be very clear, but we have to make sure these are distinct. That's really the only limitation. Then we have a colon to say, okay, I'm done with my label, I'm done with my key. Now I'm gonna put in my value. So over here, I would put in the actual string for name. And then over here, I put in the number for age, et cetera, et cetera. And one last note, notice that there's just this trailing comma at the end. You don't need that, but you're allowed to put it there. It's nice because that way if you start to add something else in here, you don't have to remember to add a comma. So, okay, so a couple other things I want to just say about arrays versus objects. The two big differences are, for one, objects have labeling. So they're really great for kind of ambiguous data like this that it would serve to be labeled. The other difference is that objects don't really have order. So of course I had to type it out in some sort of order, but it's not really built in to be in order. So you wouldn't think of this as being the first item in the object. There is no first item in the object. They're just all kind of floating around. So you don't look up things based on order, you look up things based on label now. So that's the big difference. As I briefly mentioned before, it's true that you are allowed to put different data types in an array, like a string and a number and a Boolean. But I would warn you, in most cases where you find yourself, or in a lot of cases where you might find yourself putting mixed types of data in an array, an object might be a better option for you. So when you have a bunch of really similar things, like a bunch of different cars or a bunch of different names or a bunch of different cities, an array is probably good. But if you have related data that's more of kind of a different type or looser structure, that's where it becomes useful to create an object so that you can clearly label everything in here. So there's an object for you. And just like an array, there's a bunch of cool stuff we can do with it. So let's talk about looking up. As mentioned, looking up in an object is no longer based on index, it's now based on property name. That's our label. So as with built-in properties like lengths, all of these properties can be looked up using dot notation. So check it out. If I do myinfo.name, I can look up name. If I do myinfo.age, if I do myinfo.nose.js, cool. So that's how we look up. Dot notation can also be used to overwrite. So let's say I'm like, oh, I should write out my full hometown. I can now overwrite Salt Lake with Salt Lake City. And then when I look inside of the object, I can see that this has actually been updated with that value. I could also use it to add a totally new property on. So if I wanted to do how about myinfo.car? Everything has come full circle. So I can now add my car on there, and there it appears. So I can use this to create new properties as well as to overwrite old ones. I can also use it to delete. Just like with arrays, I might want to put a null in here. Let's go ahead and overwrite. I don't want you guys to know my age. So I could overwrite that with null. I could also, though, do something even cooler. So notice that if I look inside of my info, the age is still, the property is still there, the value is just gone. So sometimes we might want to do this to keep the property, but to note that the value is missing. But if we want to wipe it out altogether, we can use the keyword delete. So syntactically, just the keyword delete followed by the object and the property. So if I delete the entire property off there, now it's just gone altogether. It's like it was never there in the first place. So that's how we can use dot notation to update arrays, to look up values, to overwrite values, et cetera, et cetera. Okay, let's say that I had a variable called town. It was set equal to Bisbee, or no, it was set equal to, wait, what am I doing? Just kidding, backtrack. Let's say I have a variable called key, and it was set equal to, let's do current town. So key is set equal to current town, if I could spell current correctly. So what would happen if we did myinfo.key? What do you guys think? Is it going to be able to find the value of Bisbee? Well, let's find out. Turns out no, it says undefined. And that's because it's explicitly looking for something called keys. So if I put on a key, now, wait, oh, no, no semicolon. If I put on a key, now it finds myinfo.key. So we have to be careful, because if we have a variable containing a key name, then we can't use that variable name with dot notation. And this might happen sometimes. Sometimes we might have, for example, a key name coming from the outside, coming from some other piece of the code base, and we just have access to a variable name that contains a value that's a key. So how would we look things up if we had the name of a variable containing a key name? Because obviously dot notation doesn't work. Well, in this case, we actually can use bracket notation. So what we can do is actually use bracket notation to pass in a variable. So when we do this, it won't look for a property called key. It'll resolve this variable and look for a property called current town. So it turns out that, yeah, let me say this again, because I know this is a common point of confusion when you're just learning objects. So we have dot notation, and that's good when you know the name of the property. So if you know the name of the property, you can actually do myinfo.age. But we can also use bracket notation, and that's good when you have a variable containing a property name. So down here, instead of knowing what this was called, in this case we can see, but imagine key was coming in from the outside and we didn't know what was inside of this variable. So we have a variable containing a property name. In that case, we use bracket notation. When we literally know the name of the property, we can just look it up directly. So there are two ways to look up with objects: dot notation and bracket notation. And everything we can do with dot notation, we can do with bracket notation. We could delete, we could overwrite. So yeah, those are two different ways of looking things up in arrays. So okay, those are properties. Let's talk about methods now. So as you might have noticed, properties were a little different in objects, right? Instead of properties being built in, we actually write them ourselves. The same is true of methods. Let's say we wanted to create a method on myinfo. And remember, a method is just a function that would be built onto myinfo. So we could do something called say hi. So I'm going to create a method called say hi. Notice that I'm just using the same syntax here, But instead of putting in a string or a number or a Boolean, I'm going to create an anonymous function. As a reminder, an anonymous function is just a function without a name. So this bit of code on its own is just an anonymous function. We just use the function keyword, the parentheses, and then the curly brackets to say this is our function scope. So in here, I'm just going to console log. Okay. So now I have written a function, a super simple function, doesn't have any parameters, no return value. And yeah, let's see if it works. So if I do myinfo.sayHi, remember this is just a method. It's just a function by itself, so function. But if I do the parentheses, I've now called the actual function. So the logic inside of it will execute. So now I have put a method onto myinfo. And this isn't a very interesting method. Let's say that I want to say, hi, I am, and then I put on my name. I can do myinfo.name. I'm going to do this just to make things clear. So I pull out the name. The same thing, just did it in 2 lines instead. So now we're console logging my name. And so what's really cool here, let's say that I actually just hard coded out. Sorry, I'm changing what I'm doing. So let's say I hard coded out that. Okay, it would still work. But what if we changed my name? Just to D for short. Or if I wanted to get a name change and become Artemis, that's a cool name, if I can spell it. All right, so I'm changing my name to Artemis. So now this thing doesn't update because I've hard coded in my name. So that's not really good. We want the sayHi function to update with whatever is in this name value. So that's why we would actually, instead of hard coding in a value from our object that we want to use, we would actually pull it out every time. So now every single time we run sayHi, it's going to check, okay, what's in myinfo.name? That's what I'm going to log. So now it updates no matter what if I change my name, even if I deleted, this would kind of mess it up, but if I deleted myinfo.name, it says I am undefined. So yeah, that's how we want our methods to work. Methods usually work with some other property inside of the object. So make sure that you're actually looking up that value within the function instead of hard coding something in. I want to show you one more way to do this. So instead of doing myinfo.name, we could use this keyword called this. So what this is doing is it's just saying, look for the property name on the object that we're inside. So in this example, using the keyword this versus actually hard coding myinfo work exactly the same. But it turns out the keyword this is really useful, and you will see a lot more of it tomorrow. So I wanted to just introduce it to you guys. So there you go. That is how you create a method on an object. You actually create it just like you would properties. You name it, you use your colon, and then you would put in an anonymous function and define out all the function logic. You could, of course, always have a return values or take in arguments. Anything you can do with a normal function, you can do with a method on an object. The last thing I want to show you with objects is some looping. Okay, so how do we loop through an object? As you might have noticed, a for loop isn't going to work very well because for loops give us numbers, and we can't look up anything based on numbers in an array, in an object, because objects aren't numbered. They're labeled with unique labels that are going to change in every object. So it turns out that there is a loop designed just for objects. It's called the for in loop. So here's the syntax. It's actually even simpler to write. It takes a lot less thinking than a for loop. So it's kind of nice. So we use our keyword for as usual, but the parentheses, the conditions are set up a little different. So instead of our 3 conditions, we actually just do let key in myinfo. So let is, of course, we're declaring a variable called key. This could be anything. by default, it's going to be key. So this is kind of like our index in our normal for loop. This is the value that's going to be changing. So this will be changing between all the different key names in this object. So then you do in and then the object name. So really, in pretty much every for in loop, you would write let key in, and then you just put in your object name. So let's go ahead and just console log our keys to start. So we see that it automatically knows how to loop through the object and find all of our keys. So all of our properties and our method, their key names are going to be looped through. So that is how a for in loop works. So that gave us our keys out of the gate, but what if we want the values? So we of course have to look up. We know that using our object, we could look up the value using the key. So which notation are we going to use here? Is this going to be dot notation or bracket notation if we want to find our value? So notice that key isn't the actual explicit name of any of our properties, right? Key is a variable that contains the value of the key name. So when we have a variable, like in a for loop, a for in loop where this is changing, we can't use dot notation. If we did myinfo.key, it would be looking for an actual property called key. So let's see what happens here, just as a reminder of why dot notation will not work. We just get a bunch of copies of undefined because every single time we're looking for something explicitly called key. But if we use dot notation, then whatever string is saved in key will be used to look it up. So now we see the 5 values and then the function. Unfortunately, it doesn't tell us too much fun info about the function, but there it is. So for in loops, those are how we want to loop through objects. So we loop through arrays with for loops and objects with for in loops. Both really useful, just in different situations. Okay, there's one very last little example use case of an object that I want to show you before we wrap up for tonight. So, okay, let me just actually get rid of all this stuff. Maybe not. Maybe I will want it for the Q&A. I'm going to comment it out. Okay, so I'm just going to move this to the bottom so we can do something else. Okay, so functions. So this is kind of more has to do with last night's lecture on functions, but I couldn't quite show you this until tonight because it involves objects. So inside our function scope, which as we know, function scope is the magical little world that exists in between the curly brackets, where different variables and rules exist then outside of the function. So we saw that there are some things that are available in here, like the return keyword, for example. Another thing that's available inside of the function scope is something called arguments. Arguments is an object. It's kind of a weird object, but it's an object. So inside here, we have something called arguments. So this is kind of weird. Arguments refers to anything that is passed in. So notice that I haven't defined any parameters up here. I can if I want. I don't even need to. So if I call example function without passing a single argument in, notice that argument is an empty object. So no arguments, right? But let's say I start throwing values in here. Now arguments has some values. So we see that it's kind of a weird object because our keys are actually numbers, which means that it kind of works almost more like an array because we can look things up based on numbers instead of using dot notation. So it's kind of like this freak little hybrid of an object and an array. So we do look things up with using bracket notation and numbers, but if we tried to do like arguments.pop, we would get an error. That doesn't exist. So this is how we can look up how many arguments are in here. So let me explain to you why this is useful. Let's say I was expecting 2 arguments, right? And I can say, okay, let's do some stuff with P1. Let's console log P2. But what if I pass in 3 things? Now we've neglected P3. Well, I could update it, but then what if I add another argument in here? So what's tricky is we don't know how many our user can put potentially infinite things in a function call. So sometimes we're curious to see everything the user has passed in. And in that case, we could use arguments. So honestly, this is a little bit of a side tangent. This arguments thing isn't super important to know. I did, at least right now. It is eventually really useful to know. I just wanted to make you aware of it. It's a good little example of scope. It's a nice little use case of a weird little object that exists for you to use. So just a little fun thing to know about. So that pretty much wraps up my lecture on data structures. We learned arrays and objects and all the fun uses of them. You have some homework tonight. It's pretty much just a lot of creating arrays and objects. You will have to work with functions to do the homework, so definitely make sure you go over last night's lesson if you were out. I do just want to mention one thing on the homework. So we talked about this last night already, that while all the code we're doing from here out is JavaScript, where you're going to see in the homework last night, tonight, and especially tomorrow, some examples where we use JavaScript to do things related to CSS or HTML. So for example, tonight you'll be asked to create an object that looks kind of like CSS. So here's just my regular object notation. It might have some properties that you're familiar with, like color, blue, border, etc. Semicolon shouldn't be there, I'm sorry. So let's talk about what this thing is. It is a JavaScript object, right? We're writing JavaScript. This is JavaScript syntax, JavaScript keywords. This is everything we just learned about how to create a JavaScript object. It's just that the content of this object refers to something that exists in CSS. So once again, don't overcomplicate it. It's still JavaScript, even though we're kind of thinking about CSS, but it's important to know because this kind of using JavaScript objects to think about CSS type stuff is really critical when you get into actually writing JavaScript for web pages. So another little homework example that's going to force you to think in kind of this weird abstract way. So just wanted to mention that briefly. Okay, so now we have some time for questions. I already answered some array questions. Feel free to ask any more questions about arrays, any questions you have about objects, or any other lingering things you're wondering about. Okay. So I saw a little question about, let me bring this up. About this line over here. So I put this on a separate, line, right? I just went ahead and pulled out the name, saved it in a name variable. And there was a question about, well, can't you just do that? Well, let me actually call it. So my info.say hi. So yep, you're totally right that we did not need that extra line. Sometimes I like to separate it out because I think it's just a little more readable for new programmers. But you're right that because this .name will resolve to Deandra, you really don't need a separate line for it. So to be more concise, you would probably just want to do it on one line. Any other questions out there? I will say one more note on this last question, which is that the keyword this can be kind of fickle. So I am kind of in the habit of, we'll talk more about this tomorrow, but sometimes it's nice to just use the keyword this on its own line, because depending on where you use the keyword this, it can refer to different things. So I will say that to play it safe with the keyword this, Just writing it out separately wouldn't have been a bad way to go. But as it were, in this case, it didn't matter. Oh, good question. Amanda wants to know about an array of objects. Absolutely. So I'll do 2 examples of this to show you just how convoluted things can get. So let's say we had, so we talked about a student's array. Let's say we wanted to get a little more fancy with this. And each student in here has a name and a grade. Sheena is not doing well. So if we wanted a little more info about our students, instead of just putting a list of students' names, we might have this more in-depth roster where each entry in the array is actually a object. And of course, this could be an even more complex object that had address, you know, I don't know what else you would want. But yeah, so there you go. You could break it out by first name, last name. So totally normal and often useful is to fill an array with objects. I'll just go ahead and extrapolate from that question and say that you could also have an object of arrays. So let's say that you just wanted a collection of lists. So maybe the first list is shopping. So for shopping, I need avocados, limes, tomatoes, chips, because obviously I live off of guacamole. The next thing might be my, my work list, teach class, prep, teach class, answer questions, etc. So, you know, I might have another list in here. And so in this way, we could also have an object full of arrays. We could have an array full of arrays. We could have an array full of arrays containing objects. It can go deep. It can get really complicated. And oftentimes when we're dealing with complex data, we are storing them in these really confusing structures like arrays containing objects, containing arrays, etc. So it's good to start to think about nesting these things right now because it's very common. Okay, I see a couple more people typing, so we'll hold on and see what's next. Yay, okay, Kendra brought up a really great example of when you might be nest things. So there's something called a JSON file. So this is a little off topic, but good to know, so we'll just talk about it. So JSON. It's like JavaScript, but not. So JSON is basically like if you want to kind of compact an object, you would have a JSON file. So an example might be, and an example of this type of thing is, we've talked a little bit about the role that JavaScript plays into programming, which is like retrieval of data. So let's think about going on Twitter. So what will happen when you log on to Twitter is once you create, you know, actually type your login, is Twitter behind the scenes will query a database which lives somewhere off in a, you know, hard drive in the ether for all the data about all of your friends' posts. So you might have something, and then it would send back an object called something like posts. And then posts might contain, or actually posts would be an array. So posts might contain things like, you know, username, date, or, you know, some sort of timestamp. I don't know why I was going 1990 something because Twitter didn't exist then. And then text. TV99 is kicking it with the bros. And then, you know, you might have in here the next thing that pops up on your feed. So, right, this is, as we just saw, an array containing some objects. So when you actually get that, so behind the scenes, of course, then the HTML and the CSS will render this information in a nice, pretty way. But behind the scenes, this is what that data looks like when it comes in. And it doesn't actually come in as JavaScript. It usually comes in as something called JSON, which is attention. I don't want to get too deep into this because it is a little outside of the context of this, but JSON is essentially an object that kind of contains condensed data in a way that's a little easier to pass around. So yeah, JSON, it's this kind of more condensed version of JavaScript where we can pass around these objects, and it's completely super wonderfully useful when it comes to passing data between a server and your actual computer where it needs to live so that it can render on your web page. So a little bit of a tangent, but I liked that question because it gave us an opportunity to talk a little more about how what we're learning applies to actual web development. All right, any other questions? I'll give you guys a second and come up with some other cool posts. What's she gonna say? I don't know why she's going to the prom in July, but okay. I don't know. I also don't know why my fake Twitter users are these like stereotypes of the super dude bro and the super girly girl. But anyways, okay. How many cats do I actually have? Good question. I have 0 cats. But I know this, okay, I know that maybe this isn't the most responsible thing, but I really want a porch cat, like a stray cat or a neighbor's cat that sometimes comes by. And that's because I love cats, but I'm allergic, so I can't really have a cat in the house. But if I just have like a cat that comes by and I can pet, that's pretty fun. I also live in a really cool town with like a lot of windy streets and alleys. So I walk around a lot and like pet random cats. So I kind of think about all the cats of Bisbee as being my cats, though I technically do not own any. So maybe 26 isn't too inaccurate of a number if you're willing to go with my crazy logic there. Nice, we have another porch cat. We have another porch cat enthusiast out there. I feel justified. Okay, okay, sorry, I'm getting all tangential. But I was in a restaurant the other day and heard a group of people discussing how they were thinking about passing a city ordinance about not feeding stray cats. And I was like, no, don't do it. All right, well, we're talking about cats, so I think that probably means it's time to wrap up the lesson and let you guys go do your homework. All right, thanks so much for sticking with me and learning about data structures tonight. You guys are just becoming more and more nuanced developers every single night. And I'm really glad that that JSON question came up because I know that at the beginning I said, hey, JavaScript is all about web development, but almost nothing we've done so far has to do with web development. But hopefully that gave you a little insight into how these tools that we're building up actually are leading you to a point that you can design web apps and play with data behind the scenes. So that's it for tonight. Tomorrow we'll be talking about classes. I love classes. It's probably my favorite lesson tomorrow. So I'm excited. I hope you guys are too. And enjoy the homework tonight. As always, reach out on Slack if you're stuck, and we will see you tomorrow night. All right, bye guys.